Yeah, on this test coming up, this test will decide who makes an A or a B for the semester, really. Because I can't let you walk out here with an A if you can't solve trig equations. Fair enough? Just wouldn't be right. You would think you know more than you do. If anyone needs one of these purple pages, I've got some. And I can run off some more. Mr. Evans, if I show up a week from Monday to take my test and I don't have a purple page, just turn it in blank, take your F. I don't know. Because having the unit circle and the rules on the back does help. Okay? All right. Now, we're about to move up. I'd suggest you listen to me instead of doing that today, because we're about to move up a level in teaching. Write some notes. All right, here we go. We're about to move up a level. Notice all the problems that you were supposed to have worked on yesterday. And remember, you have a packet of all the assigned problems in this unit is due to me. Every assigned problem has got to be worked in that packet. All right? It's due the day you take the test. I gave you yesterday to work on it. And that was none of the ones you've worked on yet have anything where they have a number with the X or with the theta. This is the first time you've seen this. And we're going to tell you how to work it. All right? Now, this is the next level. Usually you just have like a sine of X or a sine of theta. Now we're throwing a 3X, 4X, or 2 theta in front. I'm going to tell you how to deal with that. All right. What you want to do is you want to always have your trig function isolated. Isolate your trig function, if possible. We'll talk about what happens when you can't isolate it in a few minutes. But you isolate the trig function. Fair enough? And then you don't want to have to deal with that 3x. So after you get the trig function isolated, you got the trig function, whatever this is, 3x, 4x equals. What you want to do is, and to make this easy, I'm just going to show you the easy way to do it if you write down every step. It's not easy if you skip a step. When you're putting and you skip that step before you putt, it's not good, is it? Right? You're not my golfer. Okay. She's not here. All right. Well, so what you want to do is you want to write, we're going to make theta equal 3x. That's going to be the key to the whole problem right there. And the reason we're going to do that is instead of having to solve sine 3x, we just want to solve sine theta equals square root of 3 over 2. And what we have to do is we have to make a list of the thetas. Are those the actual final solution? No, that's going to tell you what theta equals. But we can go back and figure out what x equals. But this makes it easier. Someone first hour said, Mr. Evans, is this really the easiest way? I said, well, I can show you the hard way if you want me to. And they realized, yes, what I'm showing you is the easiest way. Okay, so we take a theta, we substitute it in for 3x so that we can at least solve for the theta. And the reason we do that is because we can look on our circle and find out what theta equals. And you better write theta equals, because these aren't the x's, these are the thetas. And you look on your unit circle, and you quickly see that for sine of theta equals square root of 3 over 2, you need to be at what? Pi over 3. And where else? 2/3 pi. And you write those down. And then you listen to me closely. Is there anyone that can't look at their circle and at least get those two values from their circle? If you can't, now if you're using a calculator circle, you're going to get crushed. If you're using a circle that's not a good circle, you're going to get crushed. Anybody can't get those off their circle? You know how to read the circle. Exam 1 was all about reading that circle. All right. Here's where you got to do a few more steps. So listen closely. You went around the circle one time to find those answers, didn't you? You looked around it one time. All right. See this number right here? That number tells us we got to go around the circle 3 times and look for the answers. Not hard to do, because how much do you add every time you go around the circle? 2 pi. Does everybody agree you go 2 pi when you go around a circle? So what you do is you take these. That was from going around the circle once. You're going to add 2 pi. Now to add 2 pi, you might want to realize that 2 pi equals 6/3 pi. That might help some of you that can't add fractions. All right? 2 pi is what? 6/3. Is everyone all right with that? 2 pi is 6/3. So what we're going to do is when we go around the circle the second time, all we have to do is add 2 pi to this one. So that's going to be 7/3 pi. And then we're going to add 2 pi to this one, so that's going to be 8/3 pi. So now we've gone around the circle twice. But we've already been told we need to go around the circle how many times? 3. If this was a 5, guess how many times you'd go around the circle? 5. It's always been a 1, so you've always just gone around it once. Now, we're going to go around it again. You've got to add 2 pi. So you add that, you get 13/3. And add it here, you get 14/3. Now, if you were to go around the circle again, it would be okay, but you're just adding work for yourself. Because we're looking for the answers. We want our answers, interval 0 to 2 pi. That's what we want. We want all the answers between 0 and 2 pi. So if we're going to get all of the answers, we've got to go around the circle 3 times. Now the problem is that's the theta values. Are the theta values the final solution to this? No, we need to know the what? X. All right. Is everyone okay with getting the thetas? Let's talk about getting the thetas again. You found those, you went around the circle once. You added 2 pi, you get these 2. Now, if you went around the circle and you found 4 of these, you'd have to add 2 pi to all 4 of them, right? Okay, then you get all these. Now, let's talk about how you find x. We made theta equal 3x, so it'd be easy to get that list of numbers. Folks, x equals 1/3 of theta. Is everyone okay with that? If we made theta equal 3x, then x equals what? 1/3 of theta. So all you do is you look at this pretty list that you made, and you take 1/3 of all of them. That's going to make that one pi over 9. It's going to make that one 2/9. It's going to make that one 7/9. Everybody okay with multiplying 1/3 times all of those? It's going to make that one 8/9. It's going to make that one 13/9. And it's going to make that one 14/9. And those are all the solutions between 0 and 2 pi. If you cannot do fractions because your 6th grade teacher lets you use a calculator to do fractions, I'm sorry. Sorry. All right. Somebody says, well, what happens if we just put down the first 2? Then you don't have all the solutions. You want all the solutions between 0 and 2 pi. All right? And what keys you in that you have to do all this extra work over what we've been doing, you'll see a number in front of the variable right there. Now, ask a question. Got one? Somebody? I'm thinking of the questions I asked last time. I'm trying to cover them as we go through. Here's what I want you to notice. Your unit circle seems limited because, we didn't talk about 15 degrees and 70 degrees and all that. But notice how you're actually getting solutions that aren't even on your unit circle now. But you're still having to go what? Use your unit circle to get there. It turns out that there's just enough information on that unit circle to be able to find lots of solutions without having to have more on it. But this would be the final. This is what x equals. If you stop there, that's not the final. That's what we made theta equal. Does this original problem start with theta? No, it starts with an x. All right. I'm going to let you look at that a second. Yes, ma'am. You have a good day. I'm going to let you look at that a second. We're going to talk about the next problem. Happy? All right. Now, and as long as they all have the same number in front of the x, like if you have sine 3x in all of them, let me go ahead and work it. I'm not going to talk about it. I'm going to work it. Let's say I had this. Cosine squared 2x sine squared 2x minus cosine squared 2x equals 0. See how they both have the 2x? Is that all right? They both got the 2x? You're not writing anything down. And you're not listening to me. Yeah, get those out of here and write everything down. Man, Mr. Evans, up here. Teach it. Okay. What I would do, since they both have 2x, is I would go ahead and put my theta in now, just to solve, make it easier. All right? So I'm going to go ahead and do my little step where I'm going to make theta equal 2x. So then I get sine squared theta minus cosine squared theta equals 0. And that looks like yesterday's work. Some of y'all were supposed to be working on that yesterday. What would I do to that? I would what to this? I would factor it. Sine theta plus cosine theta. Sine theta minus cosine theta. And I would find out that sine theta, and I'm going to write the step in. Sine theta plus cosine theta equals 0. Sine theta minus cosine theta equals 0. Sine theta equals a negative of cosine theta. And sine theta equals cosine theta. Well, where does the sine theta, we're about to get the theta values. We're not going to get the x values, we're just going to get the theta values. Theta equals. Where do sine and cosine equal each other? Where do they equal each other?
Pi over 4.
Pi over 4 is one of them. What's the other one?
Negative 5 over 4.
Don't do the negative. Use only positives when we're doing this.
3 over 5.
3 over 4 pi? 5 over 4 pi. All right, I like that. 5 over 4 pi. Give me a little space here, because what happens when I say where does the positive of the sine equal the negative of the cosine, or the negative of the cosine equal the positive sine? Where does that happen at? Where are they the same value, but one's positive, one's negative? 3/4 pi and 7/4 pi. And what I want to do is I want to have these written in order, because if I don't write them in order, it just makes it more complicated. So I want to put them in order. All right, how many times did I just go around the circle? I just went around the circle how many times? Once. How many times do I have to go around the circle? Twice. So I'm going to add 2 pi, which is 8/4. So I'm going to add 8/4 right there. It's going to be 9/4 pi. Add 8/4. That's 9/4 pi. 11/4 pi. Somebody earlier today said, Mr. Evans, no, you always add 2 pi. And then 7/4 adds 15/4 pi. You stop there, you get a flat 0. Somebody says, but I did a lot of work to get a 0. Yeah, but you didn't finish. You ran halfway around the track and stopped. That's called disqualified. do I do next? I need to solve for x, right? So I look at that, and I know that x equals 1/2 of theta. So what I'm going to do is I'm just going to multiply every one of those by half. So we'll get pi over 8, 3/8, 5/8, 7/8, 9/8, 11/8, 13/8, 15/8. All right, that's all the solutions between 0 and 2 pi.
So for this question, every single one of those is split.
That's it. Every one of them. That's what just drives students nuts, is y'all are so used to going, I got the answer, x equals pi over 8. Well, the problem here is there's multiple answers. There's multiple solutions at work. There's really an infinite number. You could keep on going. I'm just letting you stop where? 2 pi. We're just stopping at 2 pi. Okay, notice, if they all have the same amount here, 2x, 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 5x, 5x, and they're all the same, that's great, because you can just put the theta in there. All right, and then work from there. A lot of steps, but is it really that hard? No. Just looking at your unit circle and being willing to work. All right, next problem. Here we go. Here we go. Sine 2x minus cosine x equals 0. What did I just do? I just told you as long as all of these have the same amount, just put theta in there, right? Now I'm showing you what to do if one of them has a different number in front of the x than the other one. Because now you can't just throw theta in there. You can't substitute theta in, would be the mathy way to say it. I'm going to show you how to deal with this. Everybody's listening. Everybody notices the difference. Key here is you see the difference. The last one had a 2x here and a 2x here. This one doesn't. Look on the back of your circle, the back of your unit circle, and I want you to see if there is a way to change sine 2x into plain old cosine x or plain old sine x or some kind of combination where it doesn't have a 2 in there with the x anymore. And someone find it on the back of their circle and tell me about it. It should start off and say something like sine 2x equals. Do you have one of those? Sine 2x equals? I trust you. See, I'm looking at your sheet because right there, sine 2 theta equals?
2 sine theta cosine theta.
So sine 2x will equal 2 sine x cosine x. What you want to do is you always want to find the trig identity that will turn this one into just plain x's. That way now everything in your problem has the same theta value, has the same value after the trig function. That's the key to working these when what's after your trig function is different. All right? Now, somebody says, is there a way to turn this one into 2x's? Probably so, but that's not the way you want to do it. It's always easier to take the larger one and break it down to the smaller one. Okay? Once you do that, you have the same thing we learned about on Monday. It equals 0. And notice there's a cosine x in both of those parts. So what are we about to factor out? We're about to factor out what? Cosine x. The good news is that since we used the trig identity there, we don't even have to worry about that 2 anymore. We just made this problem easy. So cosine x equals 0, sine x equals 1/2, and x equals pi over 2. Where else does cosine equal 0? Pi over 2, and where else? Where does cosine equal 0? Pi over 2, and where else? 3/2 or 3 over 2 pi. And where does sine x equal 1/2?
Pi over 6. 5 over 6 pi.
Okay. And notice we don't even have to worry about the 2x anymore, because did we ever change it into thetas to work this problem? No. We just kept it in terms of x and used a trig identity. So this is what you have to deal with when these aren't the same. You have to use trig identities to make them the same. And I'm going to give y'all some identities for physics next year. Let me look at the back of yours, Ms. Carlisle, because I know if I wrote it on the board, you'd have written it down. Okay, no, I haven't given y'all the ones for physics next year that I need to give you, but I will. Okay? There you go. Fair enough. So far, so good. Okay, we're going to work one more problem. Sine 1/2 x equals square root of 3 over 2. I'm going to tell you the good news on this one. Okay, when there was a 2 there, you had to go around the circle twice, right? If there was a 3 there, you had to go around the circle what? 3 times. Do you realize that all the problems you worked before were understood to have a 1 there? So you only went around the circle how many times? Once. Guess what you have to do when you only have a 1/2 there? Just go around the circle halfway. Yeah. So we'll make theta equal 1/2 x, and we'll get the theta values. And the theta values, we only have to look at quadrants 1 and 2, because we're only going around the circle how far? Halfway. So somebody tell me, where does sine theta, I'll skip a step there, sine theta equals square root of 3 over 2. Tell me, going halfway, quadrant 1 and 2, where does the sine theta equal square root of 3 over 2? In quadrant 1 and 2.
Pi over 3 and 2/3.
Pi over 3, 2/3 pi. And you don't have to keep going around the circle, folks, because it's only a half. You just go halfway around the circle. Then you want to know what x equals. Well, x equals 2 theta. So this time you're not going to take those values and divide them by 2. You're going to what? Multiply them all by 2. So x equals 2/3 pi, and x equals 4/3 pi. Just realize on these you only have to go halfway around the circle. If you go all the way around the circle, you'll get 2 extra solutions that are good. They're just going to be bigger than 2 pi. And we're just limiting our answers from what? 0 to 2 pi. Yes, there will be a day in your future where you will use the negative angles in quadrant 4. We're not there yet. Yes, there will be a day when we talk about writing the infinite solutions of this, or how to show that it goes on and this happens over and over. You realize any answers that you're getting here, you just keep adding 2 pi to it and it works. It would just end up being infinitely, an infinite list of numbers. Because you could add 2 pi to that, add 2 pi, add 2 pi, add 2 pi, add 2 pi, and you keep getting legitimate solutions. We just want the ones that are between what? 0 and 2 pi. You could subtract 2 pi from it and get legitimate solutions too. All right? It's just you would end up with negative solutions, and we're trying to stay between what? 0 and 2 pi for right now. Make my life easy when I'm grading to hand out the F's and the B's, the A's. Right there, folks. A or B for the semester going to happen right there. Please be working on your packets. I'm going to give you time tomorrow to work on your packet. All right? Now, anyone have a question from 6-2 that they would like for me to work on the board? This is one of those cases where, Mr. Evans, I couldn't finish 6-2. I stood at the board and said, is there a problem you would like for me to work? You should have raised your hand and asked me to work that problem, right? Does anyone have a question from 6.2 they'd like for me to look at? File 6.2. If you got one you couldn't work yesterday, you tried to work it, you want me to work it, I will give it a shot.
Can you do 16?
16, 6.2, number 16. 6.2, number 16. 6.2, 16. My daughter's not dating when she's 16. She's gonna be 21. 6.2, 16. 6.2, number 16. All right. Secant squared x. X plus 2 equals negative 1. All right, you're going to get the secant squared by itself. So you're going to do what? Subtract 2, right? So you're going to get secant squared x equals negative 3. You're about to do what? Take the what of both sides? Square root. So you get secant x equals the positive or negative square root of negative 3. We got a problem. Because what happens when you take the square root of negative 3? You're about to get what in your answers? I's. So if you said. Because you're going to get secant x equals an imaginary number. Can't be on your circle because it's an imaginary number. Yes, sir?
Okay, so every time you do the square root, it's always going to be plus or minus?
Yeah, always. If you're putting a square root in a problem, it's plus or minus. And that's the reason, okay, if you see x squared equals 25, all right, stay with me. If you see x squared equals 25, you put the square root in there, you get positive or negative 5. Fair enough? If you look on the ACT test and they do this, they'll have square root of 25. And that's in the original problem. They have the square root sign. Then the answer is just 5. Because